Okay, sorry. So the last video cut off the very third setup here for how to solve this problem for how much excess reactant is left. So let me go ahead and start from where I left off right here. So we talked about this setup right over here, which is giving you a calculation setup for excess reactant. And this time you guys started off with 100 grams of the N2H4, which was our limiting, and then you're making the N2O4 your B, and you're going to get 143.6 from there. Now, the third way that we could do, and this is the very, very last thing I'm going to talk about today, so this video should be a lot shorter, is you could start off with the setup like this right here. So we have 131.31 grams of N2. So this right here is your A. I believe this is where the video left off of earlier. So the 131.31 grams of N2, if you remember where we solved for that before, it was when we were doing the calculations for stoichiometry earlier on, and we got this as our theoretical yield. So we're going to start off this time with this as our A, and then for the B, similar to the last problem that we just did, we're going to go to N2O4, which is the reactant that was your excess. Okay, so this was my excess reactant, so we're going to start from here and then go all the way out to here this time for the AB setup. So if you look through your calculations here using stoichiometry, we have 131 grams of N2, and theoretically this is how much could get made total, and we're just seeing at the very, very end how many grams of N2O4 we actually need for that amount of N2 to get made. So we start here, you're going to switch it out to moles, we do the mole-to-mole switch in stoichiometry, and then you go to grams of N2O4, and look at the answer that we got right over here, the 143.6 grams. It's the exact same number that we got from this setup right over here. So we could see that, again, it doesn't matter which way we do it, but we're going to get to the same answer at the end. Ooh, and I don't know why that just got canceled out, but I'm going to put this back up on the screen. And remember, for setup 2 and 3 like this, one thing you want to keep track of is that the amount that we solve for here, the 143.6 grams of N2O4, this is how much we need, but we actually had more than that to start off with. So remember how we had 200 grams of N2O4 given to us in the problem. So that is what we're going to be using over here. So we have 200 grams of N2O4 that was actually given to us to start off with. This is all we need though. So if you subtract this 2 out right here, you're going to figure out how much of the N2O4 we have left over. So how much of the excess we have actually left over here. So again, the 200 grams, we subtract out the amount that we needed for the N2O4, and then by subtracting it at the very end, we get the 56.4 grams of N2O4. And just to recap, this problem setup's a little confusing because you could do it in 3 different ways. I highly recommend just memorizing or sticking with one method and using that every single time. Because if you try to switch around from one method to another, it's really easy to get confused here. So if I go back to the screen before this, so the very, very first method we talked about was this method over here. So we're using the 51.6 grams of N2. We got that from subtracting out these guys over here. Okay, so we had an A of the nitrogen product, and then the B we went to was to the N2O4. So this is method number 1. Okay, you do the subtraction early on. So we subtract initially here, and then you go over here and use that number for stoichiometry, and you go to B for the N2O4. The B that we're always going to be using is always going to go to N2O4. So regardless of whether you start with the N2 or the N2O4, it doesn't matter. The N2O4, the excess reactant, is always going to be your B, whether you use method 1, 2, or 3. Now, looking at what we just talked about, again, these are just things we've already done. You also have setup number 2 here. So this was setup number 2, and we could also solve the problem using setup number 3. Okay, in setup number 2, what we did was we started off with the limiting reactant. Okay, and we took the 100 grams that they gave us to start with, and again, my B is always going to be the N2O4. Okay, in this scenario, though, remember that after you get the N2O4, that number you subtract out from the original amount of N2O4 that they actually gave you. Okay, the third setup, this is the third way again you could do this, is earlier we solved for the theoretical amount of nitrogen from doing the 2 stoichiometry setups early on. I'm taking my theoretical yield, so I'm going to just label this my theoretical, my TY. So we took the theoretical that we solved for before, and that becomes my A over here. Okay, and then my B, again, is N2O4. Okay, but again, just keep note that if you do method 2 or 3, you do have to do the subtraction step at the very end, whereas if you do it in the method of number 1, you subtracted first and then you did the stoichiometry. Okay, so that's it. Thanks for listening to the entire lecture. We're pretty much done covering everything. I will go through and we'll do some practice with the limiting reactants tomorrow, and I left you guys little quick homework assignment with the sub today for you to complete. So if you have any questions, you could kind of go back and watch what you need or rewatch, and then we will definitely go over this again tomorrow in class. All right, thank you.